Hi friends, welcome back. Today we are going to solve LeetCode problem 1209. Remove all adjacent duplicates in string 2. So this problem is of medium complexity. So before we go through the description and some examples, I just want to mention that my channel is focused on helping people who are preparing for coding interviews and Java interviews. My channel covers like over 200 solved problems, the coding problems asked in big tech companies like Amazon, Google, Microsoft, Facebook, Yahoo, and many other companies. And those constitute different variety of problems such as dynamic programming, graph, binary search trees, binary trees, uh, then linked list related problems, string related interview questions, and other logical and optimization problems as well. So if you are preparing for coding interviews or Java interviews, please subscribe to my channel now. My channel can definitely help you in your job interview preparation. So please subscribe. So let's go through the problem description. You are given a string s and integer k. A k duplicate removal consists of choosing k adjacent and equal letters from s and removing them, causing the left and right side of the deleted substring to concatenate together. We repeatedly make k duplicate removals on string s until we no longer can make the deletions, right? Return the final string after all such duplicate removals have been made. It is guaranteed that the answer is unique. So let's they have given us a couple of examples here. The constraints is s dot length is between 1 and 10 raised to 5 inclusive. K is between 2 and 10 raised to 4, so it is very big actually, as you can see. And s is only contains lowercase English letters. So let's take the second example over here, so we can discuss what the problem is and how we are going to solve this problem. So basically, let's first understand what the problem is, and then we will go through the how we can solve this problem. So as you can see, the input string is given for this one, right? And then what we have to do is whenever we see any consecutive three k characters, right? K is 3, so 3 characters we have to remove it, right? So for example, if you see this E is consecutive 3 times, right? So we have to remove this. After that, if you go forward, then you will see like this C is again 3 times, so we have to remove it. After removing this C, now this B will be concatenated with these two B's, right? Which will make 3 B's now. So we have to again remove these 3 B's basically, right? So after that, when we see a D, this D will get concatenated with this D, which was concatenated with this D. So these are 3 Ds. So we have to again remove the 3 Ds that we are seeing here. So which will leave us with the string AA, and that is the answer that we have to return, right? As you can see it here. So 2s is the answer for that string. So this is the problem, right? So we have to find out like consecutive k characters, and whenever we see consecutive k characters, we will be removing those characters from the string, right? And we will be joining with the remaining parts of the two remaining parts of the string together again, and we will keep doing it as long as we can, right? So once we reach this point where we have 2s, we cannot do any deletions because this is just 2a's, right? And k is 3, so in that case we have to return the 2a's basically as the answer. So this is the problem. So let's look into the details of how we can solve this problem. So we are going to use a stack to solve this problem. So our stack will be holding integers, right? And integers will be the count, right, of when we are traversing the tree, traversing the string. In this direction we will keep the count of the characters here, and that is how we will be solving this problem. So let's go and through this example and understand how we will be implementing it. So when we are like reading the first character D, we will just insert 1 here, right? The count of this character is 1, and we will go forward, and then we will see E, right? So we will compare E with this D, so it is not same, right? So we will insert 1 here, right? Then again when we see this second E, now we will check the previous character that we have visited. So previous character we have visited is same as the current character, right? Both are E's. So in that case we will increment this 1 to 2, right? We will increment this 1 to 2 in the stack. After that we will go to this E, and again we will check the previous character is same as this E, right? This E and the previous was also E. So what we will do is we will remove these two actually from the stack, right? We will remove these two from stack, and we will actually we also will be doing appending these strings into string builder, right? String builder we will use. So first when we saw D, we will append the D to the string builder, right? Then we had appended double E's here, right? Two E's we appended to string builder. When we are seeing the third E, we are removing these two E's, right? Basically when we are seeing the third E, so now we are left with just a one character D, right? So now we will keep going forward in the string, right? So now again we are visiting D. So D we will check with previously seen character, which is D after removal of EE, right? Because we will always keep checking against the string builder, right? So now the string builder has D, and now we are character we are seeing is also D. So we will go to the stack and we will increment that 1 to 2, right? Because as you can see 1 is remaining now, right? So we will increment it to 2, and then we will move forward to B, right? Now this B, so now B is not equal to D, so we will add that 1 here for B. Then we will again see B, so we will check with the previous character which is B, so we have to increment this 1 to 2, right, in the stack. And then we are going to seeing C, so C is not equal to the previously seen character B, so we will add 1 here into the stack for current character C. Then C again we are seeing, so we will increment that C to 2, right, because the previous also character was C, so it becomes 2 here. And at the same time we are also appending these characters to the string builder, right? So now we appended D here for this D, then B, B, C, C, right? Then B we appended, then B we appended, then C, C we appended, and now we are seeing third C now, right? We are here, we are seeing the third C. The previous character we had seen was also C, so which means that we already are seeing the K consecutive C's, right? So we will remove this from stack. We will remove this 2 from stack, so 2 is gone from the stack, and we have removed these 3 C's from the string builder also, right? So this is the approach we are going to take. So now we are visiting B. So once we see B, then we will check the previous character. Previous we will check with the help of string builder, right? So string builder has previous B now, so B is matching to B. So now we will we will check the last stack counter, right? So it is 2 for B, right? So we will again take this 2 out from the stack, right? Because now we had appended B here for this B, right? And now we are seeing 3 consecutive views, this B, and this B. So now we are seeing 3 consecutive, so we are removing this 2 actually from the stack. So now our stack becomes B, B, B will be gone, string builder from string builder, and our stack is left with only 2, right, for the D's basically, right? For the D's, everything else we are removed, so now 2 is left in the stack. Now we are going and we are adding D into the string builder here, right? String builder we added D, and at the same time we checked what is the previous character that we have, right? D is previous character, so we will check the count is now 2, so we will remove it because it is now 3, right? Total 1, 2 and 3 D's are coming, so we will remove all the D's from string builder, right? So at this point when we are at D, our string builder become empty basically, right? Now again when we see A, we will put 1 here in the stack, and we will append A into the string builder here, right? We will append A, and again we are seeing A, so we will increment the count from 1 to 2 into the stack, right? And then we will append A here to the string builder. Now we are at the end of the string. We will just take out the characters from the stack. We will take actually the sb.toString we will use to get the a string, right? And we will return it as our answer, right? So this is a string that we will get from the string builder, right? And we will return it. So this is the way we are going to implement remove all adjacent duplicates, and these duplicates are with k characters, right? K can be anything, right? It can be a very big number also, k, as you can see here, right? So k can be very big number also, 10 raised to 4. So we have to keep this logic using the stack, and then it will always keep incrementing the count, and when the count reaches 2 and when we are seeing a next consecutive character, then we know that we are seeing k consecutive characters. So we have to take that counter from the stack out, and we have to remove those characters from the string builder, right? So this is the approach. So let me show you the code now for this solution. So first I just got the length of the string that is given to us, and then we created a string builder here, SB, right? And then I created a stack of integers called as count stack here, right? Because we our stack is holding integer values of count of the every characters that we are seeing, and we are iterating through the string here, right? 0 to n we are going, and at the time we will read current character from the string using caret, and we know the sb dot length, right? The string builder dot length we will read into the size. So when the size is greater than 0 and current character is equal to the previous character, right? In that case, we will get the count. We will pop the count out, right? For example, in the case, right, when let's say this is the stack, right? When we see, let's say first D, we will put 1 here. In case now after that, we will put 1 for E, right? 1 for E we will put. So when the next E comes, this next E comes, so at that time we will pop that out, and we will check, count plus 1 is less than k, right? Because count is 1, so it is less than 3. Count plus 1 is 2, which is less than k, right? K is 3, correct? Then we will just increment the counter and put it back into the stack, right? So which means that we are incrementing this from 1 to 2. That's what we are doing here, right? And we are also appending that current character to the string builder, right? As I shown you here. So here we will keep appending the current character E here, then E here, right? Like this. So if we are finding count plus k, count plus 1 is equal to k, right? Means we are finding 3 consecutive characters. In that case, what we are going to do is we are going to take out the last 3 characters from string builder here, right? So for example, as you can see E here, right? So after 2E, when the third E comes, we will remove these 3 E characters from the string builder, correct? So that is what we are doing. SB dot set length and size minus k plus 1 will basically remove those 3 characters, the last 3 characters that we added here. That's what it does basically, right? So and then if the size is greater than 0, or if the current character is not matching the previous character, then we will simply append it to the string builder and push 1 to the stack, right? That's what we do, right? So if we are seeing a brand new character, let's say D, right, then we will just put 1 for the stack. When we see E first time, then we will directly put 1 into the stack. So that's what we are doing here, because the previous character is not matching with current character. So so we will keep doing through 0 to n. We will go through all these characters into the string, and then we will keep this doing this operation, right? And at the end, whatever like is left in the string builder, we will just return sb dot to string, right? For example, as you can see, 2a's left here, so just we will just put 2a's here as the string, right? And we'll return it. So this is the approach. So we used, this is for loop, so it is a order of n, because we are iterating through each n characters that we have in the string a, right? And we are going to use a string a stack for holding the characters. So maximum space complexity will be also order of n, and time complexity also will be order of n of this solution. So let me just write down here. So time complexity is order of n, and space complexity is also order of n, right? Because of the stack we used here, and we are iterating through all the n characters, n being number of characters in the given string a, right? So that is the algorithm complexity. So let's just go ahead and let's just take some examples and execute those examples here. So first test case we are doing here. So it should give us ABCD because there are no consecutive two characters. So we are getting the correct answer here. Let's just go ahead and the example that we just discussed here. So we'll just execute that example here and make sure we get two A's here. So we are getting two A's. So correct answer we are getting for this example, right? And then let's just go ahead and use all the examples that are given here, right? So let's just go ahead and run these things. So we are getting correct result for all the examples. So we'll just submit our code. So our code got accepted by LeetCode. It is almost 70% faster than other solutions and 66% faster on the memory side, which is a good solution. So this is how we can solve remove all adjacent duplicates in a string 2 problem with the help of stack and StringBuilder. So if you haven't already checked my playlist for LeetCode and LeetCode solutions on my channel, please check it now. It has over 200 solved problems explained with Java code and examples, and those were handpicked problems that constitute variety such as dynamic programming, graphs, binary search trees, binary search related problems, linked list, string related interview questions, optimization problems, priority queue related problems, and many logical problems that were asked by big tech companies in their tech interviews. Also, if you are preparing for telephonic interviews, there is a playlist called as Java interview that discusses frequently asked telephonic questions regarding Java. So if you are preparing for Java interviews, this channel will definitely be helpful to you. If you find this solution helpful and if you like this video, please hit like and subscribe it. Your subscription is really important to us because that is the way the video can reach to more people. They can also watch these videos while they are preparing for their coding and Java interviews and get helped by seeing these examples and videos. So please subscribe to the channel, and thanks for watching the video.